Welcome to the session 2 on technology, materials, sustainability of the 7th Livenarch conference. I'm Beyza Karadeniz. I'll be chairing this session, which will run from 2 p.m. until 3. There will be 6 talks today, and each presentation will be 7 minutes long. And after all the presentations are completed, we can have some time for questions and answers. So please feel free to pose any questions for our presenters in the chat box. If everyone is here, maybe we can wait 1 or 2 minutes. I cannot see how many participants in the session right now, but I think we can start. The first paper is by Hüseyin Emre ILGIN, Markku KARJALAINEN, Olli-Paavo KOPONEN from Tampere University in Finland. Mr. ILGIN will be talking about Dovetail massive wood board elements for multi-story buildings. So we can start the video now for our first presenter.
Hi, Emre ILGIN from Tampere University. Today I'm going to present you dovetailed massive wood board elements for multi-story buildings. After introduction part, historical background of dovetail joint technique, and then the current state of the art of dovetail massive wood element, then research method, finally conclusion. I'm going to present. Due to its substantially lower carbon footprint compared to traditional materials and many positive impact on the environment, together with its technological advance, wood in the form of engineered wood products has come back to the break into the multi-story building construction, as seen in the figure. Mios Tornet and Hoho as wooden tall buildings. Owing to the easy coupling technique, airtightness and high rigidity, engineered wood products such as CLT is competitive, especially in multi-story wooden buildings. In engineered wood products, adhesives play an essential role by making structure light and strong and moderating the expansion and contraction. But due to the toxic gas emissions, adhesive use has negative effect on climate change and human health. Additionally, metal connectors in these products harm their reusability and recyclability. Thus, there is still room for a solution that is solid and completely pure wood, enabling as healthy indoor air as possible. Adhesive, metal-free, connectors-free, dovetailed massive wood board elements based on one of the oldest joining methods. In history, dovetail technique is a joinery method most used in carpentry, including furniture, cabinets, log buildings, and traditional wood frame structures. The history of this technique goes back to before Christ. Some of the earliest well-known examples were in antique Egyptian furniture, stone pillars at temples, old churches, and Japanese traditional building. As seen in the figure, a stone pillar from a temple or a church, the dovetail corner detail from Poland. There is a limited number of studies on dovetail massive wood elements. To date, previous studies about this element is based on a few research, mostly about structural analysis and model testing of several types of joint details, as seen in the figure, rather than even evaluating overall technical performance of a structural component such as column, beam, or shear wall. As a research method to generate geometrically original and structurally sound digital models and to build prototypes of dovetailed massive woodboard elements, architectural and structural design software will be utilized. After that, with the help of a wood factory in Finland, designed models will be turned into prototypes. As a next step, performance tests on structural properties, fire, sound insulation, and moisture transfer resistance, and finally air tightness will be conducted. As a last part, a timber construction organization will be visited to meet with stakeholders to find the right slot for dovetailed massive woodboard element in the current timber construction market in Europe. And conclusion, this study aims to increase the competitiveness of Finnish large-scale industrial timber structures at the local level and to support European climate policy as a part of bioeconomy and sustainable development. At present, the uptake of dovetailed massive woodboard elements for commercial applications is limited, but due to new research, for example our research, DOMWOP, namely dovetailed massive woodboard elements for multi-story building, this innovative concept will be further used. You can see our concept drawings in the figure, concept model for dovetail massive woodboard elements.
Thank you very much, Mr. Ilgin. So please pose any questions into the chat box, and we can discuss them at the end of the session. So we can continue with our second paper today, and it's again by Hüseyin Emre Ilgin and Mehmet Halis GÜNEL from Middle East Technical University, and their presentation will be about contemporary trends in supertall building form, aerodynamic design considerations. So we can start the video.
Hi, Emre Ilgin. Today I'm going to present you contemporary trends in supertall building form, aerodynamic design considerations. First, I'm going to start with the building forms: prismatic, leaning, tapered, setback, twisted, and free forms. And then aerodynamic design considerations, major and minor ones. Finally, conclusion. A typical supertall building could be divided into three main parts: top, main body, and base. Here, building form classification is based essentially on main body part, as seen in the figure. Supertall building forms are prismatic forms with or without architectural top, leaning forms, tapered forms, continuous and non-continuous, setback form, twisted forms, linear and non-linear, and finally free forms, sculptural free forms and articulated free forms. Prismatic form refers to building whose two ends are similar, equal, or parallel figures, whose sides are identical and whose axles are fully vertical. It can be divided into two groups, with and without architectural top, as seen in the figure Park Avenue in New York or Marina Tower in Dubai and Makkah Royal Club Tower. Leaning form refers to building with an inclined form. Buildings have traditionally been constructed vertically, but when a building is constructed in a tilted form, it is typically an indication of some serious problems, as in the case of Tower of Pizza. And some example here, Porto de Europe complex in Madrid or Signature Towers in Dubai. Then, tapered form refers to building with a tapering effect by reduced floor plans and surface area through the height. where floor plan's dimensions are reduced constantly as the building rises. It can be divided into two groups, continuous and non-continuous tapered, as in the cases of Jeddah Tower or Ocean Heights in Dubai. Setback form refers to buildings with recessed horizontal sections through the height of the building. In this form, the plan dimensions are reduced at a certain level as the building rises, as in the case of Burj Khalifa in Dubai or World One in Mumbai. The next group is twisted form, refers to buildings with progressively rotating floors or their facade, as then multiply upward along an axis by inputting a twist angle. It can be divided into two groups, linear and non-linear twisted forms. Kayan Tower or Lagda Center is the outstanding example for this category. And then free forms refers to building out of the aforementioned form, like Alhambra Tower in Kuwait City or Taipei 101 in Taipei. And the next, aerodynamic design considerations can be divided into two groups: major modifications, building orientation, aerodynamic form, plan variation, and aerodynamic top. And corner modifications and air passes are from minor modifications. Major modifications could noticeably change the overall architectural design. They play an important role in reducing the effect of wind on supertall building. For example, aerodynamic forms, as in the case of Shanghai Tower or Pearl River Tower. Another subcategory, plan variation, is in the case of Tianjin CTF Finance Center, and as a final category, aerodynamic top in two International Finance Center or Kingdom Center, as seen in the figures. And the last category for aerodynamic design consideration is minor modifications, such as corner modifications and air passes, don't considerably change the overall architectural design. As seen in the figures, modifications to corner geometry, such as recessed, cut, slotted, or rounded corners. And the other subcategory, air passes, as in the case of 432 Park Avenue building or Aspire Tower in Doha. And finally, conclusion part. As a result of becoming increasingly taller, high slenderness ratio, and low natural frequency, inherent damping level, and high wind velocity at upper levels, new generation of super tall buildings have been more sensitive to wind loads. Their architectural trend seems to create an overall architectural form integrated with aerodynamic concerns, namely aerodynamically adaptive architectural forms. Thank you for listening.
Thank you. We can move on with our next presentation. The next paper will be on the evaluation of environmental sustainability in the context of operational and embodied energy on exterior wall, examples of hotel buildings from Istanbul, by Ezgi Yıldırım and Fatih Yazıcıoğlu from Istanbul Technical University. We may start the presentation.
Dear participants, I am Ezgi Yıldırım and I am an architect. What I'm going to talk about today is this topic named the evolution of environmental sustainability in the context of operational and embodied energy on exterior wall. Examples of hotel buildings from Istanbul, prepared by me and YAZICIODLU. The subject can be looked at under the following headings. Firstly, I'm gonna start with problem, aim, scope, and methodology of this study. Next, I am gonna show slides about exterior walls and environmental sustainability and exterior walls. Then I would like to point out some etudes in the world. And finally, I would like to address the case study and conclusion. And the question is, what are the problems leading to this research? As we all know, greenhouse gas emissions and accordingly, climate change and environmental degradation are the most problems in today's world. These problems are originating in human activity, unfortunately. European buildings are responsible for 40% of world's energy consumption and 36% of greenhouse gas emissions. In addition, 75% of these building stock is energy inefficient. Therefore, there is a need for energy efficiency in buildings, sustainable architecture, and environmental sustainability. Considering these problems, this study aims to evaluate the exterior wall of a big part of the building envelope regarding environmental sustainability criteria in line with operational and embodied energy through examples of hotel buildings from Istanbul to state the amount of operational and embodied carbon dioxide and makes suggestions for more sustainable solutions of buildings during the design phase. Moreover, to emphasize today's designers and researchers attitudes towards these issues in the world. The methodology consists of the selection of keywords, literature review related to these keywords, auto sample selection study, and the evaluation of the case study and improving suggestions as regards evaluation results in the end. The scope is examined from 4 aspects. The geographical importance of Istanbul and gradually developing building stock in Istanbul effect on choosing hotels from various locations in this study. Hotel buildings are evaluated because of being comfort-oriented and having high user requirements. Buildings constructed after 2010 are defined temporal scope. Exterior walls of the hotel samples examined. I should pass these slides about literature review because time limited. By looking at attitudes in the world, about this attitudes in the world, there are many research. Eden and Create developed building information modeling to predict embodied and operational carbon. Ibn Muhammad and the other aim to demonstrate the increasing proportion of embedded emissions as a result of efforts to reduce operational emissions. It also discussed the need for policy. Zhang and Fang state that the use of coal boilers for heating causes the highest operating emissions, while the solar heat pumps causes the least emissions. Bolotsky and the others conducted a global survey about LCA. It is seen that the designers applied or familiar with operational energy and carbon dioxide more in their daily work instead of embodied energy and carbon dioxide. Besides, the lack of environmental regulations is one of barriers to use LCA. And now the case study. For the evaluation of this study, 5 hotel buildings are selected. First, the operational energy calculations are conducted. U value of exterior walls and annual heating energy from them are calculated. The threshold value for exterior walls in Istanbul, 0.57, is considered according to Turkish standard 825. It is assumed that natural gas is used for heating of hotels. The amount of carbon dioxide emissions from natural gas is also calculated. Secondly, on the calculations embodied energy, the amount of embodied carbon is considered. For this purpose, the amounts of embodied carbon dioxide of exterior materials are provided by ICE study of Fatih University. Lastly, U-value, the amounts of embodied and operational carbon dioxide is compared, and also the amount of carbon dioxide causing from the annual heating energy for 50 years is compared to the amounts of embodied carbon dioxide and interpreted. First total is Wishmore Hotel, Istanbul. The photo, exterior walls details, project information, and the calculations of this hotel is shown here. The other hotels include same information. And by looking at the evaluation, this table gives us all results related to 5 hotels. According to these results, rock-wool thermal insulation materials is used in all buildings. U values are lower than 0.57. All meet the necessary legal requirements. High thermal performances reduces the carbon dioxide emissions from heating energy for 50 years. Different details and materials having various densities and amounts are caused to different values from embodied carbon dioxide calculations. Insulated metal panels cause the most embodied carbon dioxide, and natural stone and wood-based coatings provide the least carbon dioxide. The aluminum composite and expanded metal mesh and structural fixing elements carrying to claddings increase the amount of embodied carbon dioxide. And thermal insulation layers have a big share in the amount of embodied carbon dioxide. Although thermal performance is increased with these layers, carbon dioxide emissions are increased. The carbon dioxide emission amount from the manufacturing of exterior walls meets operational use-related heating from them in an average of 80 years. Consequently, while exterior walls of hotels have a high performance as part of operational energy, they cause negative impacts in terms of embodied energy. Even as designers consider the use of materials that will keep a thermal performance high in exteriors, they ignore the environmental effects of these materials during the production phase. Due to the environmental sustainability conditions, materials must be selected to provide optimum values. Turkey has standards and regulations about thermal performances and other, but there is a need for legal requirements on sustainability and environment, including embodied carbon and energy. To sum up, these topics discussed until now are recently analyzed in the work. And we hope that this study raised awareness and helped the future research in Turkey. Thank you for listening. If you have any questions, please don't hesitate to ask. You can find further information on our paper.
Thank you very much. And now our next speaker is Seda ZAFER from Altınbaş University. Her presentation will be on virtual way of remembering and forgetting of place. We may start her presentation.
Hello, my name is Seda ZAFER. I would like to present my paper, which name is Virtual Way of Remembering and Forgetting of Place. The virtual dimension, which has no head and no end, is flowing space without interruption, and the non-physical transformation of space through social media extend its existing uses of built environment beyond the measurable features in urban context. One of these feature is memory, and we can see that social media tools are not only recorded, transported or transmitted spaces of the collective memory, but also the environments in which the connectivity is reshaped and produced. This study tried to reveal conceptual pattern between collective memory, urban space, and social media. It's thought that spatial remembering and forgetting will gain different dimensions. These thoughts constitute the motivation of paper, and the question of is it possible to reveal the spatial collective memory and definition of place with shared data of social media and ensure its continuity is a basic search for this article. In the focus of encountering with urban space, how social media can contribute to collective memory try to be revealed. In theoretical base, it's explained that the widespread adoption of social media has changed the paradigm shift, and in the last 10 years, it's increasingly the place and space are isolated from the context to which they belong and gain the scaleless position in the effect of internet. People become aware of other users and their locations in the online map, or users store their memories in certain place with some tools, some social tools like Instagram story, let's say. By the social virtual patterns in physical terms, the users describe his or her relationship with the place through participatory or narrative displacement features. Social media tools are existing in the space as they are interface also shape the memory of the space, and they create different way of seeing special access and user behavior. We can see the layers that social media is creating in this diagram. It's very obvious that the concept of place differs as an external collective memory production through these media tools. Data shared with social networks and short-term agenda are not deleted from the internet's memory. So today's media tools are allowing to see images of places. This situation shows that communication channels are not only recorded, transported, or transmitted spaces of collective memory, but also the environments where the memory with connectivity is reshaped and produced. Images, videos, and dates and time, descriptions, hashtags provide collective representation of urban life across separate dimensions. Unlike other social media apps, especially Instagram, image and location-oriented format makes it apparent that it creates a cityscape for locals and visitors alike. Therefore, it is useful for architects, urban designers, and planners to understand what kind of potentials can be used for the future urban memorial research. The other way, the non-direct ways of communication are directed towards images. The combination of the words of Instagram, instant camera, and Telegram is named as a way of communicating through images. It progresses as an application expressing the right now, right here situation. Users upload photos, include their accounts, as we know, and follow the other people's posts, and it is becoming very interesting location focused, and this location becomes place, and the place try to be stored as memory. Therefore, it's possible to view data point as meaningful places that people know, share, and remember. So we can say that anonymous space becomes the place that is a part of recorded and shared moments. As a supportive example in this paper, architecturally, I would like to continue Atatürk Kültür Merkezi, Atatürk Cultural Center, AKM in short way, in Taksim Square, which is among architectural work of the early Republican period of Istanbul, and it is a very great representative collective special memory as architecturally, and it's come to the fore frequently from the years 2003, since there are so many ideas about demolition and replacement of another design, and now it's already demolished, and now it's building new of it. And this kind of process, it's very coming to the fore from 2010, which is redefining the facade of the building with some posters and so on, and it was becoming very collectively how I can say cultural space announcement on the some social tools, redefining the different this building with the with its important features like leafless square component after the period when it was closed and inactive, the visitor photos of the building before it was closed, and iconic staircase in the foyer were shared extensively on platforms such as Twitter and Facebook to keep its memory up to date. During the demolition in 2019, it lasted 3.5 months. Daily post Instagram stories, which were able to stay on virtual media for 24 hours. Also, some posts that they want to give the emphasis of this building as very important collective memory for the citizens. At the same time, the citizens of the city have become part of collective communication with the comments made on public spaces as this virtual dimension. This situation also results in becoming associated with the tools, even though they have no experience in that place, like meeting or joining attending to the opera. So we can conclude that the informational layer of social networks combined with traditional methods in special readings of the city, so it will give new types of guides, like changing the previous imaginability idea can getting more Instagrammability. The space is becoming more followed with their memory by the Instagram post, and the context of the geographically and geotag activities, interestingly, part of collective memory. Place-defined media tools beyond the fixed storage make memory, mobility, and human scale both temporary and incorporate social life. Thank you for your listening.
Thank you very much for a very interesting presentation. So today's session's 5th presentation will be by Merve Bilginer, Şensin Aydın Yağmur, from Yıldız Technical University, and Konstantinos Sakantamis from Aristotle University of Thessaloniki. The title of their paper is An Investigation on Physical Environment of Earth-Sheltered Buildings. We can start. By the way, please feel free to pose any questions in the questions and answers box. I cannot see any questions posted yet.
Hello dear audience and welcome. I am Merve Bilginer. Today I'm going to talk about my study, which is consulted by Şensin Yağmur and Konstantinos Sakantamis. It's named An Investigation on Physical Environment of Earth-Sheltered Buildings. I researched this study around the keywords of earth-sheltered buildings, sustainability, cave dwelling, and building physical condition of underground houses. The methodology is searching papers such as thesis, researches, then questionnaires, books, making questionnaires, following architecture magazines, and having experience of earth-sheltered buildings. The most important literature for this study is Measuring People's Perceptions towards earth-sheltered buildings using a photo questionnaire survey by Heba Hassan and others. Using the term as an earth-sheltered house is a euphemistic way to use underground house. The term "an underground" gave people bias. Malcolm Wells, who is the father of modern earth-sheltered architecture, devoted his life to break this bias with his sketch, books, and architecture. The main matter is the use of earth mass against building walls or roofs as external thermal mass. So this reduces heat loss and maintains a steady indoor air temperature throughout the season. The historical process is divided into 4 eras throughout the example. The first one is a more generalized era as a background. Second is earth shelter emerges as the new term. The third is the modern sense of earth shelter, and the last one is future expectation and possibility. The earth shelter architecture is not a new issue, as in the earliest prehistoric era. Before man knew how to build shelters, they made use of the natural environment to provide them with shelter. One of these shelters existing caves. In history, there are underground cities and underground dwellings, and also some underground dwellings are still used by people, were in China and Tunisia. After the Industrial Revolution and because of the energy crisis, earth-sheltered architecture was rediscovered by some environmentalists. Some of the pioneers are Malcolm Wells, Michael Hare, Peter Wedge, and etc. In recent years, architects worried about the adaptation of the environment for their design. With this concern, there are some perfect projects adapted to their environment. In the study, those projects are used as examples to change people's bias. The earth-sheltered building can respond to some problematic theories in the future. The first theory is about extreme climate conditions. The earth-sheltered building will be chosen as the best option by people, such as Copenhagen example. The second theory is about the increased population. Singapore finds the solution with Singapore Underground City project to the issue. Another theory is solving problematic heritage areas. The competition of Ebola, there is a futuristic project called Earthscaper, designed by BNQR Architecture. Earth shelter architecture is not common today because of some reason, and the first reason is people have biases about it. The study tried to break bias via showing modern examples and aims to be in the literature for increased knowledge about the earth-sheltered architecture. Study includes a web-based survey. The survey was conducted with 32 people, which mostly relevant in the architectural field. Firstly, I tried to measure knowledge by asking the description and whether they heard the term. It was determined that people close to the field of architecture were aware of such structures. 12 people nearly described the meaning of earth-sheltered building. It can be concluded 40% of candidates had knowledge or so of what earth-sheltered is. The experience is another issue have prejudice. 75% of the samples haven't experienced such structure. In the literature, the cross-section, which is shown in the presentation, was examined before, and in this study, the reaction of samples is also relevant with the former, which made by Heba Hassan and others. The type, which has a courtyard and is fully underground, is found not suitable for human habitation in the participants' consideration. The most suitable style is the ground level type for them. After the evolution of the typology, samples rated the levels of comfort conditions under the given topology and description. These results are important to understand what people think the earth-sheltered building, and they are used for comparison with modern examples in the next step. The first example is Alani House, which has provided all earth-sheltered house requirements and take advantage of it. And the project won the Greek Prenesse Awards in 2009. The house has 4 courtyards, which protects the rooms from direct solar penetration. Green roofs stabilize the interior temperature. All but acoustical comfort conditions are voted higher than the former. The participants in this survey are close to the idea of earth-sheltered habitation as housing. Another example is main library at Aristotle University of Thessaloniki. The subterranean library, in my experience as a user of 2 libraries building, is quieter and more comfortable for the library user. especially since it's sheltered from direct solar sunlight. But it's surprising, thermal quality and acoustic comfort are rated lower, and just air quality comfort of the underground library is considered better by the participants. The function of the building maybe can cause confusion in the participants' mind, but the participants in the survey decided that the underground library is comfortable. Thank you for the listening.
Thank you very much. So our final presentation for this session will be by Refia Güngör and Nihan Engin from Karadeniz Technical University. And they will be talking about mobility in microhouse competitions.
I am Refia Güngör. I am studying PhD at Karadeniz Technical University. At the same time, working as a researcher assistant at Kilis University. In this section of the conference, I'll present a study that's prepared with Professor Nihan Engin, and the title of the paper is Mobility in Microhouse Competitions. This study composed of 5 headings, that is abstract, mobile architecture, microhouse, microhome competitions, and conclusion. Abstract, as in all files, it's usual to describe the buildings that are preferred by less in the field of architecture, which have not become widespread, that we are not used to seeing around us as other. Mobile structure have been the primary structure or other structure according to the mobility of the people or societies. One of the mobile structures that we can refer to as another structure is microhouses, which are much smaller than today's houses. In this study, the other concept is discussed through the mobility capabilities of microhouses via microhome conditions. Mobile architecture, the correlation of mobility and architecture dates back to the time when mankind lived as a nomad. The use of mobile structures, which are the primary living space of nomadic societies, has changed in terms of usage priority with the change of the way of life of people. So much so that with the decrease in mobility of the person who moved from nomadic life to settled life, mobile structures were replaced by non-mobile structures. Thus, while the primary living space of societies and individuals are stable, mobile structures have become other structures. Microhouse. Microhouses are houses with relatively less usable areas compared to the houses we live in. Dimensionally, although there is no official square meter restriction, structures with an area of less than 28 square meters are called microhouses. However, they can be as large as 46 square meter and as small as 8 square meter. Microhouses, which are become very popular in recent years with different purpose and approaches. Most common purposes are economy, sustainability, and free. Microhome competitions. The aim of microhome architectural design competitions is to seek innovative ideas to better serve our changing world against the problem of increasing affordable housing crisis and the depletion of natural resources in the face of climate and economic crisis. The only project requirement is that the total floor does not exceed 25 square meters. Mobility is not required for competition. Total of 12 projects that won first, second, and third awards, and 3 honorable mention in Microhome 2019 and Microhome 2020 design competitions were examined under the heading of mobility, construction material, off-grid system, and motivation. And analysis tables were created with the information obtained. the heading is the tables analyzed. Mobility with the reference to the mobility classification of tiny houses under the headings of fully mobile, partly mobile, and permanent house. Structure material under the headings of traditional structure material and innovation structure material. Off-grid systems under the heading of a solar panel, rainwater collection system, and grey water treatment system. Motivation under the headings of sustainable living, economy, and minimalism to reveal the main purpose of structure. Conclusion: mobile buildings as a symbol of the lifestyle of today's people have found their place in many different functions, especially in housing. Micro houses are also mobile houses that emerge as a reflection of the new lifestyle and that developed with human mobility. In this study, a total of 12 designs that won awards in 2 competitions were analyzed with tables. As a result of the analysis, the following conclusions were reached. Mobility: most designers designed a mobile structure as a solution to the problems they determined in the competition, where the condition of being mobile is not required, shows that the tendency towards mobile thinking in architecture has increased. Structure: in mobile projects, materials such as wood, steel, 3D construction material, and recycled plastic are used, while stone and concrete are used in 2 of the 3 permanent structures. This shows that the structural material is effective in the mobility of the building, and the structure should be light enough to enable the structure to be easily transported. Off-grid system: in the projects examined, at least one of the solar panel, rainwater collection, and rainwater recovery system was used. It showed that the mobility type of the structures is not effective in the selection of these systems. Motivation: all of the projects examined are designed in light of at least one of the motivation for sustainable economy and minimalism to solve the location of the structure or a global problem. With the prominence of mobile structure is computations where ideas and problems are clearly expressed, and innovative and original approaches to future problems take place. It makes it possible to think that mobile structure can take their place in the center of architecture by living the studies of other structures. Thank you for your attention.
Thank you. So I think we come to the end of all presentations. I would like to thank all of our presenters for their illuminating presentations. So now we have 10 minutes, exactly 10 minutes for questions and answers. I am checking the questions and answers box, but I cannot see any questions yet. So maybe we wait a few minutes for the questions. Still no questions. Maybe I can ask a question to Seda ZAFER. It was really interesting, and I think it relates to my profession as well. I'm an urban and regional planner, so this urban space focus was really interesting. I'm curious if you have ever considered what is the future of overall architectural space, because now we can create an virtual space that we can experience. So how do you see the future of this, I would say, series of, it's almost like an attack on humankind. I think there are some benefits of social media, of course, but I feel like we are losing the connection to the actual space. We put too much importance in. So
thank you. Thank you so much for your impressions. I can think that these kind of social media tools will be very main part of our lives, and it's changing our behaviors at the same time. So maybe the definition of the place and its memorial understanding also, or the perception will be changed, and maybe we will not realize that it's because we are going to be changed through these elements, but these tools will be a very big part of them. Maybe the tools that we are researching, and maybe it can create its own methodology. We can also try to think with those methodologies are ever changing with these effects, I can say. I can see this is in the future, it's going to be very big part of researching, I think. It's very possible to find reach the emotions for the spaces or places, or reach the memories for the spaces and becoming the places. But at the same time, I agree, it's very hard to keep this as a memorial part, because it's ever changing. But I think it will be in kind of medium to combine this more realistic memorial part of the place, or this virtual way of the remembering space, I can say.
Thank you very much. So any other questions for our presenters? We have still 5 minutes, so please feel free to ask any questions.
Maybe I can offer a comment for Seda's research again. I am Konstantinos Akadamis. I was supervising Merve, but I am also active in architecture, urban design, and environmental design. So Seda's research was really very interesting for me as well. We have been, actually today we have presentations of our research projects for the 5th year course, and we had again research that I was supervising about collective memory and how this is shaped through fairy tales or things that we usually learn from our grandmothers. What we found is that the survey was done between architects, architecture students, and mostly our 4th and 5th year students replied. What we found is that the primeval concepts of the tower or magic forest or the hut, which are central to the questions of understanding and having an image of these primeval conditions, is very much influenced, at least 60 or 70%, by modern iconography of the Disney or other, cultural media, which are really targeting younger populations. So since we are talking about a generation that has been brought up after 2000, let's say, and we have younger researchers, this kind of focus on how media actually influence us and how, again, it comes to our understanding of the world, whether this is real or whether this is in an imaginary or surreal state. This means that despite what we see in the social sphere, where we have different teams of people grouping around the social media and a very big, let's say, difference in views of how we perceive the world in terms of our, collective perception. In terms of the images, because they are so powerful and can be embedded in our psyche in such a way, we have a prevalence of a not so much a local culture, but of an international culture. So we have the ability to see where we are in terms of a globalized society. And I am afraid that what these images do is that they create a fixed convergence, whether we like it or not. So this becomes central to what Seda is doing, I think. I would put this much more efficiently as a question, on how, especially what you showed about buildings that don't exist now, which I think is transgressing the theme. It's a very good case study, because then you can know about this loss and this recuperation, and it can become clear that it's collective memory or hidden memory, or if you delve deeper into that, I think it will be great.
Thank you very much, Konstantin. I think we have 3 more minutes, and I'm curious to hear some more questions, but let me check the question. No open questions still. So maybe we can close the session now. Thank you again once to all the presenters and also the attendees. I think it was a great session and very interesting topics. Hope to see you in the following sessions. And
On behalf of the Livenarch committee, we thanks Dr. Beyza Karadeniz and all participants for their contributions. Now we will take a break. We will meet again 15:15 for the keynote speaker, Professor Dr. Esra Akcan presentation. We wish you all an interesting and informative days with lots of networking. We thank you.
thank you. Bye.
So much.
Bye. Thank you for the hospitality.